Welcome to the Walton Pi. Today we're going to be talking about a relationship that exists between derivatives and continuity of functions. So a short but useful theorem to know is the relationship between a function being differentiable and a function being continuous. That theorem says that if a function is differentiable at a, then the function is continuous at a. Now, it's important to note that this is not a both direction thing. We can't say that if a function is continuous, then it's differentiable. This theorem only works in this one direction. So a counterexample to the opposite direction, so assuming it's continuous, that means it's differentiable. An example to show why that is not true is the function f of x equals the absolute value of x. If we look at this function, it's going to be continuous everywhere. But it is not differentiable at x equals 0. It is continuous there, but it's not differentiable. So if we look at the graph at x equals 0, we can't figure out what the slope is at that point. If we approach from the left-hand side, the slope would be -1. If we approach from the right-hand side, the slope would be +1. So we can't figure out what the derivative is at x equals 0 because it just doesn't exist. And so that's an example to show that continuity does not imply differentiable. There are continuous functions that are not differentiable. So let's go through a proof to show why a function being differentiable implies that it's also going to be continuous. So if we assume that f is differentiable at a, then the derivative of f at a is equal to the limit as x goes to a of f of x minus f of a all over x minus a. So if we look at the limit as x goes to a of f of x minus f of a, well, that's just going to be equal to f prime of a times x minus a. And so if we evaluate that at x equals a, we do find that that is going to be in fact 0. So limit laws tells us that this means that the limit as x goes to a of f of x is equal to the limit of f as x goes to a of f of a, which is just the limit of a constant, so that's going to be equal to that constant. Therefore, the limit as x goes to a of f of x is equal to f of a, which is the definition of continuity at x equals a. So that is a completion of the proof. Therefore, any function that is differentiable at a point is also continuous at that point. I hope this video was helpful. Please check out some of my other videos if you haven't already, and please like and subscribe so that I can continue to make these sorts of videos in the future. Best of luck and have a great rest of your day.